Hello everybody, it's been a few days since I posted a video and I'm still doing these after the fact, so I don't have any way to live stream or camera set up yet. I did get my video computer down here. I haven't got it set up and running yet, and I'm also getting ready to move my offices to another commercial location instead of where I'm at now. But I'm getting ready to hire a second person, so whenever I encounter real tricky problems, I like to save the chips so that I can turn around and insert them back into a board and train somebody and see how they think their way through it and then help them understand it. So this is an A1466. It came in for no backlight. This is one of my commercial customers that I do work with on a regular basis. Just to go over this, when you have no backlight, it's a pretty straightforward circuit. You check to see if you get voltage here. Usually a backlight circuit here, you're going to get, at the least 18 volts here. If the driver's not working, U7101, you would just get 8 volts there. But in this case, I wasn't getting even 8 volts here. I would like to go over the backlight circuit here. Then this is the actual board. I want to go over this backlight circuit just a little bit so you can get an understanding and troubleshoot these, because there is some steps that have to happen first before this turns on, and I just want to kind of explain this a little bit. And this, I wish somebody explained this to me. I watched so many Louis Rossmann videos and he's like, oh, I just fixed this little bit of corrosion and this worked and that worked. But you really have to understand the flow here and how this works. So when you first power on the machine, the PCH is going to load the BIOS, it's going to do a bunch of stuff, and that's actually, in this case, as part of the processor. And the first thing that happens, and you may have to wait 3 to 5 seconds for this to happen, is the CPU, PCH will set an enable here, and this will turn on the 3v3 logic to turn on the logic onto the screen. And that goes through this screen ribbon cable here. And this here is actually the board inside your screen. So once the 3v3 logic comes into the screen, well, then the logic on the screen here, it will start communicating with the PCH, and it will tell the PCH, hey, I'm attached, yeah, let's go. And then once the PCH is happy on the CPU, the next thing that's going to happen, and it happens pretty quick, maybe less than a second, it will send an enable signal here to Q7707, and Q7707 will enable this FET, which is Q7706, to allow this 8 volts to go through this FET and charge this buck converter. Once this buck converter is charged, then it's going to get driven by U7701. And the U7701 basically has some feedback circuits to monitor the backlight voltage, and this is all just backlight here. It will have some feedback circuits to monitor the backlight voltage. There's one of them. It's a little via, and on these boards, it's very common that corrosion damage this right here, and you have to scrape this off and run a jumper and fix it, because there's high voltage on the via, because this backlight circuit gets anywhere from 16 to 45 volts. So the higher the voltage, the quicker it gets chewed up by corrosion. On this board, I noticed right away, I always do a physical observation before I drop to mental troubleshooting, because a lot of times you can just fix it by seeing what's wrong. Somebody had changed this diode. I could tell right away that this was not the original solder. This is solder that someone had replaced. So someone had replaced this diode, because this was not the original solder. The next thing I noticed was this was not the original fuse. The original fuses are brown. This one's blue. That was not the original fuse. So I went ahead with the screen attached, and I checked to see if I got 8 volts here. I didn't. I got nothing, which is unusual. Usually if I got something wrong with the backlight driver, which is U7701, I'll still get 8 volts here because the buck converter's been charged, but I won't get any boosting. and because U7701 is not boosting, but I'll still get 8 volts. So not having any voltage here tells me right away, excuse me, that I have either a bad fuse or it's not being, this FET's not being turned on. So I did verify that the PCH turned on Q7707, but Q7707 was not pulling down the enable on this FET. And in this case, with this FET, you have to pull it low to let the 8 volts go through and charge this circuit. So I realized right away that the CPU was sending the enable, which is this little metal pin. And if I can get over this, they see that gold tab right there? That's where the enable comes from this processor. But the output, which is supposed to pull this down, was only 2.7 volts, not low enough to turn on the FET. And I saved this part because this is very odd. This is the first time I've seen Q7707 fail in this way. Nothing was shorted. I checked this out, ohmed it to my 8 volts. It was fine. Nothing was pulling this high. I checked these 2 resistors, and they were both the correct values because these are meant to protect the circuit to turn this on. And I'll show you that real quick here. So see these 2 resistors right here? This is my 8 volt rail up here. This is my PPVN, PP bus G3 hot. This is around 8.5 volts. So this 8 volts here, because of the direction of that arrow, this has to be low before this FET turns on. I didn't get my 8 volts. So this needs to be low. It was at 2.7 volts. It was not at 0. I checked this chip, which is the Q7707. My enable was present. My LCD backlight disabled. It was not being disabled, but this was not pulling low. So you definitely want to check these 2 resistors, because if the resistance on this, right, especially this one, if the resistance on this, if there has to be resistance there before it can pull it low, because if there's no resistance here, it's not going to have enough power to pull it low because this voltage will stay here. So this is a voltage divider, and it protects this circuit from, you know, either this chip failing or this chip failing. This voltage divider makes sure with 301K and 147K that resistance is high enough that not enough current will go through to damage either one if one or the other breaks. So that's why that's there. But 2.7 volts here would not turn this on. And you know, from looking at this schematic, I'm like, well, the only thing left, because everything else is what it's supposed to be, will be this IC. And it was. After I changed this IC, pulled this down, this turned on, 8 volts. Let's look at that on the schematic, on the board layout, the board view. So here's my FET. This is my enable. Q7707 pulls this low, turns this on, charges the buck converter. Then this thing gets a boosting and drives the voltage, and this controls the brightness and stuff like that. So it's pretty good to have a basic understanding of the backlight circuit, and the previous repair technician, I don't think, had that understanding, and that's why they got stuck. So this is the backlight driver itself. This is U7701, and I could see where they put some green glip on here on these resistors, and I seen how this was replaced. It wasn't in great shape, but it was balled properly and it was on there. So I did some quick measurements on this, and it seemed a little cattywampus. My diode checks didn't read what they normally read, so I replaced this, and presto, I had backlight. So that's the fun thing when you're chasing somebody else's work. So what had happened is, you know, I don't know what caused this to be damaged, if it was technician damage, because this is a pretty rare chip to fail. You really don't see that. Fail at all. So I don't know if they shorted something out and damaged it, and they replaced this. But regardless, you had to think your way through this because this enable was not turning on the 8 volts. So I replaced that, got that going. This seemed a little funny, replaced that, and I have backlight. So I'm getting ready to test the machine right now. Okay, so let's test this thing. I did get a little bit of a backlight on the bench, but let's put it in the machine. I've got my test keyboard plugged in. I don't boot off the customer's drive. I've got an SSD drive plugged into this Apple keyboard because it has USB ports on the side. So I got it plugged in. Let's go ahead and fire this thing up. I hear a chime. That's a good sign. Yeah, we got backlight. It's working just fine. So what we were dealing with is a compound problem. I don't know the original cause. It could have been this FET up here, Q7707, could have been the source of the problem, and they just changed U7701. My guess is it had some water damage around U7701, and they did something and shorted out Q7707. Like the output for the LCD backlight enable low was probably stressed out, and the chip no longer had the ability to pull that down. So looks like we've got a working machine here. I'll show you how I QA these really quick. When I first started doing these, I wasn't QAing them properly and I got burnt. So I just want to show you some of the things I do really quick. So this is my test OS. This is not the customer's drive. This is the one I use for these MacBook Airs. So one of the things I put on here is an older version of HW monitor. And this is very important because this will show you all the sensors in the machine. Now notice some of these are red. That's just because it just turned on. And the CPU sometimes is a little warm when it first turns on, but none of these are crazy out of line. And after a few minutes of it loading things, these will come back down. So none of these are like crazy temperatures. If I had a bad sensor, these would read like 129, and these would be off the charts. Excuse me, guys, I have a cold. So my fan spin is normal. All my sensors are reading normal. My temperatures are all within the range. I know that doesn't look like it, but it is for these. Apple just runs them a little hotter, I guess. So after I bring up hardware monitor, the next thing I will do is I always do photo booth because I want to check to see. There I am. I want to check to make sure that the EyeSight camera is working. So always bring up photo booth. I will go ahead and pull up my disk utility just to make sure it sees the customer's SSD. This is my external SSD, and it is seeing the Apple SSD on the machine, so I know it's reading the SSD okay. I go ahead and make sure my Wi-Fi is connected. That tells me the Wi-Fi is okay. I go over to Bluetooth. See if it sees my Bluetooth devices. There, it's seeing my Bluetooth devices. This is one I always have kind of running my wireless keyboard and stuff, so it found them. I go to run coconut battery. You can see the charge cycles here, 19, which is fairly low for these, and I can see that it's communicating with the battery properly. I will bring up a typing program, and I will just kind of go through and hit these keys just to make sure that all the keys are working and they're not sticking on the keyboard. Make sure cap locks and shift. So my keyboard's working okay because I'm checking all these keys. So my keyboard's good. That's part of the QA test. I know my USB port is working. If this one's working, unless there's something wrong with physical damage, but I visibly inspect that. I usually don't test the HDMI output on these. I usually don't test that HDMI output, but unless there's damage in the area, I will check it by just physically inspect it. Haven't been bit by that. The only time these are bad is when someone jams something in there and they break it. So that's good. Then I go ahead and I check to make sure I got sound. You can see what that file is. I don't want to play too much of that, or YouTube will probably flag me for copyright infringement. So, photo booth, the drive, Bluetooth, the battery. I will sometimes run Nova Bench. This is an older version, which is really clean and fast to run. So let's run that just to see if the performance is in the window. Excuse me, I got a little bit of a cough here. But this is all kind of part of the QA testing. I like to make sure that when I'm sending out a machine that it's going to work properly. And the old version of Nova Bench is way better than the new one. It runs really fast. It doesn't take a long time. And when you're QAing, the last thing you want to do is spend 15 minutes running benchmarks. I just need some basic quick tests to make sure the CPU and everything is running in the window. And you can see the CPU is getting warm because it's kicking some ass right now. .573 is a little low, but there's probably something running in the background, so let's run that again. Let's see what this is first. This is a 4 gig machine. That might be not too bad. It's an 8 gig. Okay, so this should be a little faster. Let's just run it again. What I've found with Nova Bench is sometimes you have to run it a couple times just to make sure. And I was moving the mouse and poking around on it, so that makes it run slower. But I can tell right now that's normal for video. It's running just fine. This tells you what it is. Is it an i5? Yeah, it's an i5. It's pretty important, especially when you're mailing these things. Is this thing running warm? I think I am going to re-glip the processor. Sometimes the Apple heatsink compound isn't the best. So let's change the processor heatsink compound and see if we can get some better numbers here. That might be causing the machine to throttle just a bit. I think 554 is a little low, so let's do that. Okay, so I replaced the Apple factory heatsink compound, and you can already see a significant drop in the temperatures of the machine. It just booted up, so it's no different than it was, just a few minutes ago. The only difference is I changed the Apple factory heatsink compound. They do not use the best stuff in the world. I use Electrotherm, which is some name, who knows, but the key is it's a white silver heatsink compound, and it's a much better performing compound than what you would find that comes with the machine. So it does cost a little bit more. This tube I think was around $10, and it's not very big, it's very small, but it has lasted a year, because the key with heatsink compound, as you've seen in some of my other videos, is use just very little. The purpose of heatsink compound is to eliminate air gaps between the heatsink and the chip substrate. So you use a very, very small amount, and then you move the heatsink around and squish it so you've got all the air out, and then you tighten it down. So with this type of stuff, less is definitely more. You don't want to be using a whole bunch of it. And but look at the difference that made. I don't have anything in the red anymore, and all I did was change the heatsink compound. So that's another reason I always run hardware monitor on these machines. And a lot of times that Apple heatsink compound just isn't doing it. So let's go ahead and give Nova Bench another score and see if we can beat 540 now. This is all part of the QA. Even though I fixed the problem, I want to give them back a machine that I know is going to work perfectly. So the only way you know is to check your temperatures, your sensors, and do a speed test. So let's see how this runs now, since we don't have anything in the red. Now let's watch the temperatures as they go up. Nothing bright red though. Well, once, but that's Apple. So let's see what we end up with here. I mean, you can see it's working, but nowhere near like it was before. Look at that, 623. See what a difference a little bit of heatsink compound makes? So when you work on these, double check your temperatures and make sure that everything's right. You know, a lot of people would not have caught that, but it's worth taking an extra 5 minutes or so, and it's pretty common that you have to change his stuff because the stuff Apple uses isn't the best. And you know, when a machine gets older, it can dry out, but it shouldn't be a problem as long as that heatsink is stuck to that chip and doesn't move. It can dry out, but that made a big difference, just heatsink compound. But that's how I QA these things, and I just wanted to go over that as well. And a successful repair, even though someone tried before me.